Uh, Welcome to new video. Uh, this video, we shall continue with our chemical kinetics. In the first video, we discuss rate of reaction. Two ways in which rate of reaction can be measured, which are average rate of reaction and instantaneous rate of reaction. That is what we discussed on in the first video. Before I move, welcome to this video, our great students. Good morning, good afternoon, good evening, depending on the time you are watching. This is NeoTisa. NeoTisa is committed to give you the best of the best. My name is what? Tosin Omonito, also known as Jama. In this video, we shall discuss factors affecting rate of reaction. Factors affecting rate of reaction and rate law. Let me write those things we are going to discuss here. Factors affecting rate of reaction. And we shall discuss rate law. Rate law. Factors affecting rate of reaction, which is what? ROR, rate of reaction. Then we shall discuss rate law. Let us take the first one. Factors affecting rate of reaction. The first one. Factors affecting rate of reaction. We shall discuss all the factors that affect rate of reaction. The first factor, we have physical state. Physical state of reactant. Physical state of what? Reactant. Mostly solid. Physical state of reactant. Mostly solid. Let me quickly explain this using an example. When you have silver triazonitrate in solid state plus sodium chloride in solid state, both of them are in what? Solid. This will affect the rate of this reaction. In this case, where you have both reactant in solid state, this reaction cannot occur. This reaction cannot occur. They won't be able to react because the molecules are in solid state. The molecules won't be able to what? Interact with what? Each other. This reaction won't occur. It won't occur. That means it will have little rate of reaction, or it will not what? Occur. But when you have silver triazonitrate aqueous of both, you have sodium chloride aqueous. When you have both of them in aqueous state, this reaction is what? Very high in what? Rate of reaction. The rate of reaction of this will be very high. It will occur in microseconds because both of them are in what? Aqueous state. They will interact with each other. They will interact with what? Each other. Comparing to what? This, in which both are in solid state. It won't react. This one, the reactant won't react. That means the reaction won't occur. But when they are both in solid state, they will not react. That means the rate of reaction will be very high. Take note of that. Let us move to another factor. Number two. Number two, nature of reactants. 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 Let me first of all explain with this under nature of reactant. When you have molecular reactants. If you have molecular reactant means one covalent reactant. covalent reactant. For example, when you have nitrogen gas reacting with what? Hydrogen gas. Don't forget, each of them, nitrogen gas exhibits what kind of covalent bond? What kind of bond rather? Covalent bond. It exhibits triple covalent bond. This one is what? Single covalent what? Bond. This is covalent what? Reactant. When you have covalent reactant reacting with what? One another or each other to form this ammonia. Ammonia gas is formed. Balance equation, ammonia gas is formed. This reaction we have a very low rate of reaction. Low rate. Because this bond between the triple bond between the what? Two atoms of what? Nitrogen gas and the single bond between two atoms of what? Hydrogen gas will take time to what? To break. It's a taking what? Time taking what? Process. Time taking process. The bond will take time to break. This bond will take time to break before they can form what? New bond. It's a time taking process for the bond to break so that they will now combine with each other to form new bond. That means if the reactant are molecular reactant or covalent reactant, the rate of reaction is what? Will be very low. But if the reactants are ionic reactants, the what? Rate of reaction will be very high. Example of that. Under nature of reactant. Under nature of reactant. When you have these ionic reactants. When you have ionic reactants, in which you have silver triazonitrate 5 plus aqueous. Don't forget aqueous, sodium chloride, aqueous. In this case, both of them are ionic reactants. When you have silver ion, nitrate ion, you have sodium ion, and chloride ion. The electrostatic force between these will break easily, so that new compound will be formed. The new compound that is formed, you have silver chloride, which will be precipitated plus what? Sodium triazonitrate 5. This reaction is very has a high rate of reaction compared to the first one I wrote. Ionic reactant has higher rate of reaction compared to what? Covalent reactant or molecular reactant. Take note of that. Then another thing I can explain under this. When you have homogeneous reactant and heterogeneous reactant, don't forget we are still under nature of reactant. When you have homogeneous reactant and what? Homogeneous reactant, and you have heterogeneous. You have heterogeneous reactants. What is the meaning of homogeneous reactant? That means all the reactants are in single phase. Homogeneous. All the reactants are in a single phase. For example, gaseous reactant reacting with another gaseous reactant. When you have a gas reacting with a gas, that is homogeneous. Aqueous reacting with what? Aqueous. Homogeneous. Compared to heterogeneous, they are not in single phase. When you have a solid reacting with what? Gas, that is what? Heterogeneous. When you have homogeneous reactant, which all the reactants are in single phase, then that means they are all gases or they are all aqueous. The rate of reaction for homogeneous reactant is greater than the rate of reaction for heterogeneous reactant. Take note. Let me call this one 1. Let me call this one 2. That means the rate of reaction for what? This homogeneous reactant is greater than what? Rate of reaction for what? Heterogeneous reaction. When you have all the reactants in a single phase, in which you have gases, gas, aqueous, the rate of reaction will be very high compared to when they are solid aqueous or solid gas. Take note of that. Please take note of that. Let's move further to the second factor. Number 3, second factor affecting rate of reaction. Number 3, we have surface area. Very important. Very, very important. Very, very important. Surface area. Surface area. Very, very important. Very, very important. Surface area. Surface area. Listen, take note of this. For you to increase surface area of reactant, surface area of reactant, surface area of reactant. For you to increase surface area of reactant, that means you have to break the reactant into smaller units. Breaking of reactant into smaller units means increasing the surface area of the reactant. Breaking or dividing the reactant into a smaller unit means you've increased the surface area of reactant. Take note of this, and take note, rate of reaction is directly proportional to surface area, to surface area. Rate of reaction is directly proportional to surface area. And I told you, breaking down reactant increases the surface area of the reactant. For example, when you have a long, let me say a long, silver triazole 95. Let me say, okay, when you have a long calcium chloride, or let me say a granule zinc reacting with acid, reacting with acid. This one has lower surface area. But when you have a dust zinc reacting with acid, which one will react fast? We have higher rate of reaction. Don't forget, this one is, and this one is dust. This one is granule. And I told you for you to increase the surface area of a reactant, you have to break down the reactant into smaller units. This one is a smaller unit of this. This one is a smaller unit of this. Therefore, this one has higher surface area compared to this. Because this one is a dust. This one will react fast with the acid compared to when it is in granule. That means the rate of reaction for this is greater than the rate of reaction of this. Let me call this one Roman figure 1, this one Roman figure 2. The rate of reaction of Roman figure 1, rate of reaction of the first one will be greater than the rate of reaction of the second one. Take note of that. This one we have the reaction between zinc and the acid. We have higher rate of reaction compared to the reaction between the granules zinc with acid. Take note of that. Another example under this, when you have a cube of sugar, for example, a cube of sugar, when you have a cube of sugar, and you dissolve this in milk, dissolve this, drop this cube of sugar in milk, it takes longer time for this cube of sugar to dissolve in milk. But when this sugar is broken down into powder form, is broken down into powder form, and you pour the sugar in milk, what happens? The time it will take the sugar to dissolve in milk will be very small. That means this one has higher rate of reaction than this. Why? Because the surface area has been increased by breaking it down. This one has higher surface area. Why? Because you've broken this down into smaller units. by increasing the surface area. The rate of reaction, the rate at which this one will dissolve in milk will be higher than this. Why? Because the surface area has been increased. That's why once the surface area increases, rate of reaction what? Increases. How can you increase the surface area? By breaking down the solid into what? Into powder. That means you've increased the surface area. Please take note of that. Let us go to another factor. Number 4. Number 4. Number 4. Number 4. We have effect of reaction medium. Effect of reaction medium. Effect of reaction medium. How does effect of reaction medium affect rate of reaction? How does it affect? For example, when you have hydrolysis of tertiary butyl chloride, when you have this butyl chloride in aqueous ethanol, and you have pure ethanol. Look at this. This is aqueous ethanol, pure ethanol. Aqueous ethanol is polar. It's a polar solvent. It's more polar than what pure ethanol. Why? Because aqueous ethanol contains what? It contains this that make it what? To be polar. That make it to be what? Have higher polarity than what? Pure ethanol. Then if this butyl chloride, tertiary butyl chloride, is being hydrolyzed by this aqueous ethanol, and the same tertiary butyl chloride being hydrolyzed in what? Pure ethanol. The hydrolysis of a tertiary butyl chloride in this one has what? Higher rate of reaction than pure ethanol. Why? Because this one is what? Polar. Polarity affects rate of reaction. Polarity affects rate of reaction. Polarity always increase what? Generally increase rate of reaction. The only time polarity can decrease rate of reaction is when the viscosity of the polar solvent is increased. The only time, let me repeat, the only time polarity decreases rate of reaction is when the viscosity of the polar solvent is what? Increased. If viscosity of a polar solvent is increased, it will decrease rate of reaction. If viscosity of a polar solvent is increased, viscosity of a polar solvent is increased, it decreases rate of reaction. But generally, when you have a polar solvent, it affects by increasing what? Rate of reaction. It affects by increasing rate of reaction. That is why the hydrolysis of this one tertiary butyl chloride in this one polar solvent, the rate of reaction in it is greater than when this is what? Hydrolyzed in pure ethanol. The hydrolysis of what? Tertiary butyl chloride and with what? Aqueous ethanol, the rate of reaction is 30 times greater than the hydrolysis of what? Tertiary butyl chloride with what? Pure ethanol. What is responsible for that? The polarity of this what? Substance. This is the polarity of this substance. That means polarity increases rate of what? Reaction. The only time polarity decreases rate of reaction is when the viscosity of what? Of the polar solvent is increased. Take note of that. Please take note. Let's move further. Let us go to temperature. 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 Before we move to temperature, next one, let us move toward light. Intensity of light. Intensity of light. This is another factor. Intensity of light. Intensity of light. This should be number what? 1, 2, 3, 4, number 5. Intensity of light. Intensity of light. Take note. Rate of reaction is directly toward to intensity. Intensity of light is directly proportional to intensity of light. There are some reactions that light increases their rate of reaction. For example, when you have substitution reaction, the reaction between methane and chlorine gas. That reaction is has higher rate of reaction. That reaction has higher rate of reaction when it is carried out in the presence of ultraviolet light. Another reaction like photosynthesis. Photosynthesis. That's another reaction. Another reaction when you have hydrogen gas reacting with chlorine gas. When you have hydrogen gas plus chlorine gas to form ACl. In the presence of light, this reaction is very high. That means there are some reaction that rate of reaction, intensity of light increases their rate of reaction when they need light to have high rate of reaction, to be fast. Reaction between methane and chlorine gas in the presence of ultraviolet light. Take note of that. That means increase in intensity of light increases rate of reaction. Let's move. Another one, catalyst. 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 Another one is catalyst. Number 6, catalyst. 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 There are some catalysts that slow down rate of reaction. First of all, take note of that. There are some catalysts that slow down rate of reaction. We are not discussing those catalysts. And those ones that slow down rate of reaction are known as inhibitors. These are catalysts that slow down rate of reaction. They slow down rate of reaction. They are called inhibitors. We are not discussing that. We are looking at catalysts that increases rate of reaction. Catalyst that increases rate of reaction. And how does catalyst increase rate of reaction? It increases rate of reaction by creating another route, another pathway for the reaction, by lowering the activation energy. It changes the activation energy. It created another route, another pathway for the reaction. For example, when you have this, this is energy, this pathway of reaction, pathway of reaction, and you have this. This is reactant. This reactant. This product. This activation energy. Activation energy. Activation energy. This activated complex. Activated complex. Or transition complex. Take note. If catalyst is added to this, it will create another route for this reaction. It will create another path for this reaction. This is it. It lowers the activation energy. The catalyst, addition of catalyst lowers the activation energy. This is uncatalyzed. From here to here is uncatalyzed reaction. Uncatalyzed reaction. Then when catalyst is added, it lowers the activation what? Energy. It created another what? Route, another way for the what? Reaction. That means lowers the activation energy. Then the time taken for this reaction to occur will be what? Smaller compared to the time taken for this reaction to what? Occur. That means catalyst increases rate of what? Reaction. This is uncatalyzed what? Reaction. Why this is what? Catalyzed reaction. This is what? The catalyzed activation what? Energy. Why this one is what? Uncatalyzed activation energy. This is what? Catalyzed activation what? Energy. Which substance created this part? Catalyst. Catalyst increases the rate of what? Reaction. Take note of that. For example, when you have hydrogen peroxide to form H2 plus O2 in the presence of what? Manganese 4 oxide. The presence of this. That means rate of reaction is directly proportional to what? Catalyst. Catalyst. The presence of this what? Catalyst will increase the rate of what? Decomposition of what? Hydrogen peroxide. By changing the what? Activation energy. Take note of that. Let's move further. Let's move to next one. Temperature. 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 Temperature generally increase rate of reaction. Take note of that. Temperature generally what? Increase what? Rate of reaction. Temperature generally increase rate of reaction. For every 10 degrees C rise in temperature, rate of reaction is 2 times faster. Take note. For every 10 degrees C rise in temperature, that means for every what? 283 Kelvin rise in temperature. For every 283 Kelvin rise in temperature, 10 degrees to Kelvin is what? 10 degrees C to Kelvin is what? 283 Kelvin. For every 10 degrees C rise in temperature, or for every 283 Kelvin rise in temperature, the rate of reaction is 2 times faster. Take note of that. Then under this, when in the next video we shall discuss what? The law that explain the effect of temperature on rate of reaction, which is known as what? Arrhenius what? Equation. Arrhenius equation that says rate constant equal to what? A, that is pre-exponential or factor of frequency factor times what? Exponential raised to power minus what? EA. EA is what? Activation what? Energy over what? The gas what? Constant times what? Absolute what? Temperature. We shall discuss this under what? Under temperature in the next video. We shall talk more on this, on how temperature affects what? Rate of chemical what? Reaction. And we shall discuss what? Collision theory under this in the next video, where we are going to discuss this equation. And take note, when there's increase in temperature, the reactant will gain more energy that is equal or greater than the activation energy. When there's increase in what? Temperature, the what? The reactant, the energy of the what? The energy content of the reactant, will what? Will change, and it will increase. It will increase. Take note, for reaction to occur. The energy can be equal or greater than what? Activation energy. When there's increase in temperature. We shall discuss that when we want to discuss what? Arrhenius what? Law. Arrhenius equation. K is what? Rate constant. A is what? Pre-exponential factor or frequency factor. E is exponential. EA is what? Activation energy R is what? Gas constant. T is what? Absolute temperature. Temperature in Kelvin. Take note, take note, take note of that. Let us move to the last one, concentration. 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 Concentration also, it generally increases the rate of reaction. It generally increases rate of what? Reaction. If the reaction is what? Involve gaseous reactant, it will be pressure. Take note. If the reaction involves what? Gaseous reactant, it will be what? Pressure. Pressure. Let me say pressure. Pressure for gaseous reactant. For gaseous reactant, that is pressure. Take note, pressure. The increase in pressure for gaseous reactant or increase in concentration generally increases what? The rate of reaction. And how does this one increase rate of reaction? It will increase the what? The frequency of collision. It will increase the frequency of collision. It will change the frequency of collision. Take note of that. There is a question now for non-gaseous reactant. For non-gaseous reactant, which of the following will have no effect on rate of reaction? For gaseous, for non-gaseous reaction, which of the following will have no effect on rate of reaction? A. Pressure. B. Concentration. C. Temperature. D. Catalyst. The answer to this is what? Pressure. Because pressure is only for what? Gaseous reactant. That means reaction that involves what? Gaseous reactant. For non-gaseous reactant, pressure has no effect. It will be what? Concentration, temperature, catalyst. Take note of that. Then let us move to the what? Our next what? Topic for today, rate law. Rate law. Rate law. Rate law. Please, I want you to listen carefully. Rate law. Rate law. Ooh, rate law. Rate law. Rate law. What is rate law? Rate law shows the relationship between rate of reaction and concentration. That means it deals with what? Dependency of what? Rate of reaction with what? With concentration. That means it shows the relationship between what? Rate of reaction and what? Concentration. Rate law. And the dependency between rate of reaction and what? And concentration is very complex. Very complex. That means rate law can only be determined by what? Experiment. That means the only method you can use to determine rate law is what? Through what? Experiment. Because the relationship between the what? The rate of reaction and concentration of the species involved in the reaction is very complex. And the only way we can determine that is through what? Experiment. But there are some reactions that you can use what? Law of mass action to get their what? Rate law. Those reactions are known as what? Simple or elementary reaction. Let me quickly explain. What is elementary reaction? Elementary reaction. Elementary reaction. Take note of this. It's a reaction that has a single step. Single step. A reaction that has what? Single what? Step. A reaction. It can be called single reaction. A reaction. A reaction that has single step or single transition state. Single transition state. A reaction that has single step with a single transition or state. A reaction that has single step with single transition state. But when you have multi-step reaction, multi-step reaction, this reaction is also known as complex reaction. Complex reaction. Complex reaction. This is a reaction that has more than what? One. They can have two or more steps. When you have a reaction with what? Two or more elementary steps, it is known as what? Complex reaction. Complex reaction. And the relationship between what? Rate of reaction and concentration is complex. It's always what? A complex reaction. And for you to determine the rate law for complex reaction is through what? This one. The rate law can be determined by what? Experiment. Experimentally. We determine the what? The rate law for what? Multi-step reaction or complex reaction. The only way we can determine the rate law is what? Through experiment. But for this one, for this single step, we use what? We use law of mass action. We can use law of mass action. Law of mass action. Law of mass action is postulated. Law of mass action is postulated by what? Goldberg and Wages. Goldberg and what? Wages. These people, they postulated on law of mass action. What is law of mass action? The rate of a reaction is directly proportional to active masses of the reactant. Or the rate of reaction is directly proportional to the concentration of the reactant. This one can be used to determine what? To determine rate law for what? For elementary reaction. But for complex reaction, it is through what? Experiment. It is through experiment. It is through experiment. And rate law shows the relationship between rate of reaction and what? Concentration. And that relationship is very what? Complex. Complex. And that what? Dependence that is complex can be determined by what? Experiment. The rate law can be determined by what? Experiment. But for single reaction, it's through what? You can use law of mass action. Postulated by what? Goldberg and what? Wages. Let me give you an example of single elementary reaction. Example of single elementary reaction before we go to complex. How to determine rate law for elementary or single reaction. For example, when you have reaction between hydrogen gas and iodine vapor to give you HR gas. This is a single step, an elementary reaction. A reaction that involves what? Only one step. Is elementary. For you to write out the what? Rate law for this. We have rate law for this. That means rate of reaction equal to what? Rate constant into the force, the active mass of the reactant. These are the two reactants. For the first reactant, H. What is the mole? 1 raised to power 1. Then the second reactant, I. What is the mole? The mole is what? 1. That means we use what? Law of mass action, which is what? Goldberg. postulated by Goldberg and Wages to determine the rate law for this. Why? Because this is an elementary reaction. This is an elementary reaction. A single reaction. An elementary reaction. We use what? This one, this law, obey what? Law of mass action. Postulated by what? Goldberg and what? Wages. When you have the mole of each of the reactant, the mole of the reactant raised to power, the second reactant raised to power the mole, is law of rate law for this what? Reaction. Because it is what? Simple. It is a single or elementary reaction. That's why we can use our law of mass action. But when you have complex one, for example, N2O5 decomposed to NO2 plus oxygen gas. Balance the equation, put 2 here, put 4 here. The equation is balanced. This one is a single or simple reaction. Simple reaction. Simple or single or elementary reaction. Or let me write simple, can call it simple. But this one is a complex reaction. This one is a complex reaction. Complex reaction. This one is a complex reaction. You can't use what? Law of mass action. You can't use law of mass action to what? To write the rate law for this. Because rate law show the what? Dependency, which is a complex dependence between what? Rate of reaction and what? And concentration. Because this one is a complex reaction, you can't use what? Law of mass action, postulated by what? Goldberg and Wages. If this one want to use law of mass action, you have R equal to what? K into N2O5. What is the mole? Stoichiometry coefficient 2. Now put 2. For this one, you have it's a complex reaction. The rate law for this can be determined experimentally. The rate law for this can be determined experimentally. And through experiment, it is found that the rate law is what? R equal to what? K into concentration of this, concentration of the reactant, which is this. This is the true experiment. This one, true experiment. True experiment. This is true what? Goldberg and Wages. That means true law of mass action is wrong because it's a complex reaction. It can be determined through experiment. This one is a complex reaction. The real and rate law is what this. Take note of that. Take note of that. Then let's move further. Please, let's move further. Let's move further. Okay. I told you for complex relationship between rate of reaction and what? Concentration of reactant. The rate law is determined by what? Experiment. And it has been done experimentally that rate of reaction is equal to what? K into what? A raised to power 1. This is first order reaction. In first order, take note, it has been done experimentally that in first order reaction, increase when you double, when the concentration of A is doubled. Rate of reaction is also doubled. It's also doubled. In first order, rather. In first order. Take note, I will explain the meaning of order to you. In first order, when the concentration is doubled, rate of reaction is also what? Doubled. In first order. And this is first order. When you double this concentration, the rate of reaction is also what? Doubled. in first order. It has been done experimentally. Take note of that. In second order, where you have R equal to what? K into A raised to power 2. Let me use B. In this one, when you have this, in second order, this is first order. When concentration of B is doubled, rate of reaction increases 4 times. It has been done experimentally. Take note of that. It has been done experimentally. In what? Second order. When concentration of B, this B is doubled. When concentration of B is doubled, rate of reaction increases for 4 times. Let's see if it will work. Let's see. You have R equal to what? K into what? B raised to power 2, second order. And I said in second order, let me call this one equation 1. And I said in second order, when concentration of B is doubled, rate of reaction increases by what? 4. Okay. R equal to K into B concentration is doubled, 2B raised to power 2, equation 2. What will you do? Divide equation 2 by equation 1. Let's see if rate of reaction will be increased 4 times. Let's see. You have divide equation 2 by equation 1. You have R. Let me call this one R1. Let me call this one R1. Then you have R1 over R equal to what? K into what? 2B over K 2B B raised to power 2. What happened? K cancel K. This one you have. This one will give you. Let me write it here. Is it okay like this? Let me write it here. You have R1 over R2 equal to what will you have here? If we expand this bracket, you have 2 raised to power 2, B raised to power what? 2 over what? B raised to power 2. What happened? Let me. B cancel what? B square cancels B square. You have R. This okay. You have R1 over R equal to what? This one will give you 4. Therefore, R1 equal to what? 4R. Can you see? Rate of reaction. The new rate of reaction. This one is the new one. Increase 4 times. Take note. It has been performed experimentally. In first order. When concentration is doubled, rate of reaction is also doubled. In second order, when concentration is what? Doubled, rate of reaction increases by 4. In third order, when concentration is what? Third order, what we have? When concentration is doubled, rate of reaction will increase by what? 8 times. It has been done experimentally. In this one, third order, when you have third order, that is equal to what? K into A raised to power 3. When concentration of A is doubled, this one will increase what? 8 times. It has been done experimentally. Take note of that. It has been done experimentally. Let us move. Please, let us move. First order, when concentration of A is doubled, rate of reaction is what? Doubled. In second order, when concentration is what? Doubled, rate of reaction increase for 4 times, which we prove here. In third order, when concentration is what? Double. Concentration is what? Double. Rate of reaction increase what? 8 times. Take note of that. Then let's move further. Let's move. One love, one act. Let's get together and feel alright. Hear the children crying. One love, one heart. We dance and praise to the Jah, and now we feel alright. Listen, experimentally, when you have R equal to what? K into concentration of A raised to power X, concentration of B raised to power what? Y. for a reaction given as, let's say 2A plus B equal to what? Product. For Goldberg and Waji's law of mass action, if you want to express this, we say R equal to what? K raised to A raised to power 2, B raised to power this stoichiometry 1. For complex reaction, it is wrong. This reaction is a complex one. It has been done experimentally. The rate law will be obtained experimentally. Take note. When you have this, or this reaction, take note. This equation is called rate law expression or rate law equation. It's called rate law expression or rate law equation. The law, everything, the equation, rate law expression or rate law equation. R is known as what? Rate of reaction. K is known as what? Rate constant. Or you can call it what? Velocity constant. Or specific rate of reaction. When you have this concentration of reactant A. When you have this concentration of reactant B. When you have X is order of reaction with respect to A, reactant A. When you have Y is for order of reaction with respect to reactant B. Then when you have X plus Y to give you what? N. That means N is what? Overall order. Overall order of reaction. So if you know this, when you have S plus Y to give you N, that means N is overall order of what? Reaction. Take note of it. Take note of that. Please take note of that. Take note of that. This is rate law equation or rate law expression. It shows the relationship between what? Rate of reaction and what? And concentration. Take note. Take note. Take note. Take note. For example, if I have this one 3, this one 2. What is overall order of this reaction? The overall order of this reaction is 3 plus 2, which is what? N equal to what? 5. That's overall order of reaction. If you have this one, what is overall order of this reaction? 3 plus 1, which is what? 4. That is overall order of the reaction. When you have something like this, what is overall order of this reaction? Overall order 1 plus 1, which is what? 2. Overall order. If you have this 2, 3, what is order of reaction of what? A. The order of reaction of A is what? 2. The order of reaction with respect to B is what? 3. The order of reaction with respect to A is what? 2. The order of reaction with respect to reactant B is what? 3. Then the overall order is what? 5. Take note of that. Please take note of that. X, Y. Take note of that. Hope that you can pause the video and write it out. Write it out. Write it out. I have like this video should be 1 hour video, but because we want to solve some questions, I will add another 20 minutes to it. Please, please, please. Or you can solve. There's a question or 2 questions we need to solve. Let's move. Let's move. Buffalo soldiers, General Rasta, they want some buffalo soldiers. Okay, let's move. Let's move. What is K? I told you that K is what? Rate constant. And it can also be called velocity constant. And specific rate of reaction. What is the meaning of specific rate of reaction? Specific rate of reaction simply means if, take note, if concentration of all the substance or species in rate law expression is unity. Take note of that. A will take with your specific rate of reaction. Take note of that. Is there your last question? If concentration of all the species, of all the substances in the rate law expression is unity, K will be known as what? Will be called what? Specific rate of reaction. For example, if concentration of A is the same thing as concentration of B, if they are all unity, what happens? R will be equal to what? K in this case. They are unity value. R will be equal to what? K. In this case, K is known as what? Specific rate of reaction. Take note. Specific rate of reaction. Take note. If concentration of all the species in rate law expression is what? Unity, that means R will be equal to what? K. That is specific rate of reaction. Let us move. What is the unit of K? Unit of K. Very, very important. Very important. Very, very important. Unit of K. K. Take note. The unit of K depends on order of reaction. Depends on order of reaction. Take note of this, very, very important. The unit of K depends on order of reaction. Depends on order of reaction. The unit of K depends on order of reaction. And take note, I should have given you that. When you have R equal to what? K into A raised to power X, B raised to power Y. I told you S is the order of reaction with respect to A. B is order of reaction with respect to what? Concentration of what? B, reactant B. And I told you X plus Y equal to what? N. And I told you N is the overall order of the reactant. Take note, X, Y, and N can be positive value, can be negative value, can be what? Zero, can be what? Fractions. Take note of this. Take note. X can be negative value, Y can be negative value. The overall order can also be negative value, positive value, zero, or fraction. Take note. X can be negative value, it can be positive value, it can be zero, it can be fraction. Y can be positive value, it can be negative value, it can be zero, it can be fraction. N can also be what? Negative value. The overall order can be positive value, can be zero, can be fraction. Take note. Take note of that. Please take note of that. Overall order of reaction can be positive, negative, zero, or fraction. Order of reaction with respect to what? A reactant can be what? Negative, positive, fraction, or zero. Take note. Take note of that. Take note of that. Take note of that. I said unit of K depends on what? Order of what? Reaction. Then let us get the unit of K. for each order of reaction. For each order of reaction. First of all, let us get the unit of K. We have this R equal to what? K into A raised to the power what? X, B raised to the power what? Y. Let us get the unit of K for this straight law. K, make K the subject of the formula, equal to what? R over concentration of A, which is order, concentration of B, which is what? Order. What is the unit of R? I told you unit of rate of reaction. Let me explain something. Unit of rate of reaction, I've given you this one. Mole per liter per what? Seconds. That means mole per liter per seconds. If we have a gaseous reaction, take note, gaseous reaction in which instead of the concentration we look at what? Pressure, a gaseous reaction. When you have gaseous reaction, the unit of what? Rate of reaction rather will be equal to what? Atmosphere per what? Seconds. ATM per what? Seconds. ATM per seconds. For a gaseous reaction. In which all the reactants are gases. The unit for what? Rate of reaction with what? ATM per seconds. Take note. Okay, let's move. I told you that the rate of reaction, we are considering concentration here is what? Mole per liter per what? Seconds. Let me write it like this. Mole per liter per seconds. That means I will change this. Okay, now rate of reaction is what? Mole per liter per seconds over A, concentration. And what is the unit of concentration? Concentration is what? Mole per liter. Concentration is what? Mole per liter. Take note. Concentration is what? Mole per liter. That means concentration, that means mole of the substance all over what? The volume of the solvent. Take note. Concentration is what? Mole per liter. For this one, this by X. Sorry. Triangular bracket. Rectangular bracket. Yeah, it's called rectangular bracket. For this one, the concentration is what? Mole per liter raised to power what? Y. Take note. Then from here, under law of indices, when you have A raised to power n times what? A raised to power n. What are the same base? A. Then n times 10 to plus n. The same thing. This one A, this one A. The same base. Then S plus Y. Therefore, I will have K equal to K will be equal to what? Mole per liter per seconds over this one will give you mole per liter raised to power X plus Y. And don't forget, what is S plus Y? Overall order of the reaction. S plus Y is what? Overall order. Change S plus Y to N. Order K equal to mole per liter per seconds over what? Mole per liter raised to power N. Don't forget. From here, you can solve your mathematics. This thing means what? K. It means K equal to mole per liter per seconds times 1 over mole per liter raised to power N. That's the meaning. And under law of indices, when you have 1 over A raised to power X, what does it mean? It means what? A raised to power minus X. Apply that. What we have? We have K equal to mole per liter per seconds. What we have? Times what? Mole per liter raised to power minus N. Then what we have? the same base equal to what? Mole per liter raised to power what? 1 minus n per second. Take note of this. Take note of this. Please, you can pause the video and write it out. That's the formula to determine the unit of K. And we can use this formula to also determine order of reaction. We can use this formula to also determine order of reaction. Take note of that. Take note of that. This formula, do you know that I can also rewrite the formula in this form? This formula, that formula is the same thing that I can write it like this. Mole into what? Minus 1 liter n minus 1 per second. It's the same thing. This and that is the same. If you do know how to use that one to solve question, I will teach you how to use this one. Mole raised to power 1 minus n, then liter raised to power n minus 1. Yeah, this is mole raised to power 1 minus n. Liter raised to power n minus 1. Then seconds raised to power minus 1. Please take note of that. Take note of that. Take note of that. Take note of that. Let us do a question. 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 Let us move. Let us. Before we move to a question, let me give you, using this formula, the formula is this. You have order of reaction. Order of reaction. And their units. A unit of K. Unit of K. Order of reaction and what? Unit of K. Order of reaction and unit of K. Order of reaction and unit of K. We have zero order. Zero order. What is the unit of K in zero order? Zero order. What is unit of K? That means when n equal to what? 0. That's the meaning. What is the unit of K? If you use this formula, hope you've written that formula. What is the unit of K in zero order? You've written this formula. Thank you. Thank you. The formula when n equal to 0, zero order. That means you have unit of K. You have mole per liter 1 minus n per second. When n equal to 0, K equal to what? Mole per liter. That means 1 minus 0. Then you have K equal to what? Mole per liter per second. That's unit of K. That means unit of K in what? In zero order is what? Mole per liter per what? Seconds. Which you can also write like this, or you can write mole per liter per seconds. It's the same thing. It's the same thing. If I use this formula I gave to you, that mole raised to power 1 minus n, n raised to power n minus 1, then per seconds. Zero order. If I don't want to use this, I can use this. I will have mole 1 minus 0 is what? 1. Then L 0 minus 1 is minus 1 per seconds. It's the same thing. It's the same thing. You can't use this one or this formula. This formula or this formula for the unit of what? K. You can't use anyone. Then first order reaction. First order reaction. What is unit of K for first order? What is the unit of K for first order? Let me solve it. For first order, using the formula mole per liter raised to power 1 minus n per second. First order, that means you have mole per liter. First order, n is what? 1. First order, that means n is 1. That means 1 minus 1. What is 1 minus 1? 0. Then anything raised to power 0 is what? 1. Anything raised to power 0. A raised to power 0, 1. Then this one, 1 minus 1 is 0. All this one will be 1. What do you have? Per second. That means the unit of K in first order is what? Per second. If I use this one, I will get the same thing. That means I will have mole 1 minus 1, 0. This one will give me 1. Later, 1 minus 1, 0. That means per seconds. per second. For second order, what's the unit of K for second order? That is using the formula mole per liter n minus 1 per second. Second order, that is n equal to what? 2. N equal to 2. Second order, n equal to what? 2. And we have mole per liter, that is 1 minus 2. Then what do we have? Mole per liter minus 1. If I use this one, the same thing, I will get the same thing. If I use this one, that means this one, mole 1 minus n, liter n minus 1 per second. So I will get the same thing. That means mole 1 minus 2, n is what that means I will have minus 1. Then 2 minus 1, I will have raised by 1, then per second. This is what I will have, which is the same thing as this. Take note, can get the unit of order. Then look at this question. Take this question. If you have, take this question. Pause the video, write, you can write. Pause the video, you can write. Pause the video, you can write. Okay. Please subscribe. Press your subscribe button so that you can be notified for more video, and try to share this video with your friends. Comment if there's anything you want us to teach, if there's anything you want us to know, if there's anything you think we haven't done that we need to do to make it better. Please comment, and you can call one of those 2 numbers on your screen. Please take note of that. Please subscribe. Press your subscribe button. Share it with your friends. Share this video with your friends, and comment and like, please. Let's move. Let's look at these questions. The first question says, if K, rate constant, that is K, is given as 4.5 times 10 raised to the power minus 3, liter raised to the power 2, mole raised to the power minus 2, and per second. Find the order of reaction. They want you to find order of reaction. What you need to find the order of reaction, to look for order of reaction, is just the unit. That's what we need. You only need the unit. That is what we need. And what is the unit? We have L squared, mole raised to the power minus 2, then seconds raised to the power minus 1. And for first solution, and what is the unit of K? The unit of K, the formula to calculate the unit of K, and that formula can be used to calculate order of reaction. The formula says mole per liter into 1 minus n per seconds. This is the formula I gave to you, and I will use the second one. I can use this one also to get the same answer. Mole raised to the power 1 minus n, then liter raised to the power n minus 1 per seconds. I can use this one to get the answer. Let me use this one, then I will now use this one also. Please take note of that. From here, per seconds cancel what? Per seconds. Take note. Per second cancel per seconds. The meaning of this was L raised to the power 2 over mole raised to the power 2. That was the meaning, isn't it? Equal to what? Mole over liter raised to the power. Then this inverse of this, the inverse of this means this one go up, this one come down. It means I can have mole raised to the power 2. This one raised to the power what? Minus 2. This one what? Minus 2 also. Equal to what? Mole over liter raised to the power what? N minus 1. Because inverse. That means this minus means what? 1 over. That is inverse. Then this thing, what they have in common? They have minus 2 in common. Bring it out. And we have mole per liter raised to the power minus 2 equal to what? Mole per liter raised to the power 1 minus n. This cancel this. Then we have minus 2 equal to 1 minus n, isn't it? This one cross, you have minus 2 minus 1 equal to minus n. Minus 2 minus 1 will give you minus 3 equal to minus n. The minus cancel minus. Therefore, n equal to what? 3. That means it is what? Third order. The answer is what? Third order. This one, third order. Option 1, C. If I don't want to use this formula, I can use the second formula. I can use that second formula. That one is straightforward. I can use that second formula. I can use that second formula. Let me rub this one off. I can use that second formula. I can use that second formula. That second formula says mole raised to power 1 minus n liter raised to power n minus 1 per second. I can use this one. Then equate it with what? The unit from the question. The unit from this question is what? M raised to power 2, mole raised to power minus 2, then mole raised to power minus 2 per second. In this case, per second cancel what? Per second. I can take anyone, I can use mole, I will use this mole. Or I can use liter, and use this one, liter. You can pick anyone. Let me use mole. I have mole raised to power 1 minus n. Pick the mole from there. Mole raised to power minus 2. What happened? Mole cancel mole. What do you have? 1 minus n equal to what? Minus 2. What happened? Minus n equal to what? Minus 2. I mean minus 1. Then minus n equal to what? Minus 3. Therefore, n equal to what? 3. You get the same answer. If I want to use liter, I will get the same answer. You can pause the video and you can try that. You can use liter, which will what? Liter equal to what? Liter raised to power 2. Liter plus liter minus 1 equal to 2. N equal to what? 2 plus 1. I see 3. Third order. It's third order. You get the same thing. Let's move. Let's move to number 2. Second question. Let's move to number 2. Second question. What is the second question? It says A plus 2B give the product. According to the reaction, it is found experimentally that order of reaction with respect to A is 2. Order of reaction with respect to B is minus 1. That means we have rate law equation R equal to what? K. This rate law equation 2 reactant X. B raised to power what? Y. That means order of what? A. Order of A is what? X. Order of reaction with respect to A is X. Order of reaction with respect to B is Y. Then in the question they say order of reaction with respect to A is 2. That means this X, let me change it to what? 2. Then order of reaction with respect to B is minus 1. This one, let me change it to what? Minus 1. Then I now have the first question. Write the rate law. This is the rate law, number 1. You've written the what? Rate law. Option question B. Calculate the overall order of the reaction. The overall order of the reaction. This is A. B. Calculate overall order of the reaction. What is overall order of the reaction? So the S plus Y equal to what? N. Overall order of the reaction. That means we have 2 plus minus 1 equal to what? We have 1. That means overall order of the reaction is 1. That is 2 plus times minus 1 will give you minus 1. 2 minus 1, you have 1. That is N equal to what? 1. Overall order of the reaction is what? 1. Then, next question, they say, what happens on rate of reaction when, let us listen. What happens on rate of reaction? Let me rub up this one. You've done this. 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 Yeah, you've done this. That means what happens? See, what happens on rate of reaction when concentration of A is tripled alone? The rate of reaction, the rate law from the question is A, concentration of A raised to power 2, concentration of B raised to power minus 1. They now say what happened to R when concentration of A is tripled only. Let me call this one equation 1. When A is tripled only, that means I have R. Let me call this one R1. They say when A is tripled only, that means 3A raised to power 2 is tripled only. Only A. Concentration of A is tripled only. Then I still have my B like this. Let me call this one equation 2. What happened to what? Rate of reaction. What happened? Divide equation 2 by equation 1. And equation 2 I have R1 over R equal to equation 2 is this K into what? 3A raised to power 2 B raised to power minus 1 over equation 1 I have K A raised to power 2 B raised to power minus 1. What happened? This cancel this. Simple. This cancel this. What do I have? I have R1 over R equal to this one we give open this bracket 3 raised to power 2, that is 9. Then A squared over what? A squared. What happened? A squared stand to A squared. Therefore, R1 equal to what? 9R. That means when A is tripled, what happened to the rate of the reaction? It increases by what? 9. It increases by 9. Like 9 times. It increases. Rate of reaction increases 9 times. That's it. It increases 9 times. That's it. It increases 9 times. You can pause the video and do it on your own. Let's go to the next one. Let's go to the next one. We've done that. They say the second one. What happened to rate of reaction when concentration of B is halved alone? What happened to rate of reaction when concentration of B is halved alone? Only B in this case is what? Halved. Halved. That means divide by 2. Concentration of B is divided by 2. Let me rub up this one. I still need equation 1. I still need that. I still need equation 1. I still need equation 1. Okay, for the second one. Concentration of B. What happened to the rate of reaction when concentration of B is halved alone? I have R1 K into A raised to power 2. When concentration of B is halved alone, that means concentration of B is halved alone. That is equation 2. Concentration of B is halved alone. The same thing, divide equation 2 by equation what? 1. Divide equation 2 by equation 1. What do we have? Equation 2 is what? R1 equal to K into A raised to power 2. B over 2 concentration raised to power 1. We have this one by R. K into A raised to power 2. B raised to power minus 1. That is equation 1. What happened? K cancel K. This one cancel this. I have this. Do your mathematics. I have R1 over R equal to this one. It means B raised to power minus 1. Abi? Then we have 1 over 2 raised to power what? Minus 1 over B raised to power minus 1. That's the meaning. That's the meaning of this. Take note. That means the meaning of this is this. In mathematics. What happened? This one cancel this. What do you have? You have R1 over R equal to, what's the meaning of this? You have, what do we have? What do we have? What do we have? What do we have from here? We have this one, we saw 2 raised to power minus 1. Abi? That's the meaning of this. That means 1 AS, or it means what? A raised to power minus S. This thing, 1 over, that means you have this. That's the meaning. Please take note of that. You have R1 over R equal to this one minus 1 times minus 1. 1. That means 2. You have R1 equal to what? 2R. That means in this case, when B is halved alone, what happens? Rate of reaction increases by 2. Therefore, I can say rate of reaction for this one increases 2 times. 2 times. Increases 2 times. Take note of that. Take note of that. Take note of that. Let's go to the next one. Concentration of A and B are both doubled. Concentration of A and B are both doubled. Concentration of, we've done this one, we've done this one. Let's go to 3. Concentration of A and B are both doubled. Concentration of A and B are both doubled. Concentration of A and B are both doubled. Roman figure 3. That's what we want to do now. Concentration of A and B are both doubled. The equation the rate law we still have, because we are still on this question, we are still using the rate law. K A raised to power what? 2. B raised to power minus 1. And I say, when concentration of A and B are both doubled, we have the second rate law, this one equation 1. We have equation 2 as A. A is doubled. Likewise, B is what? Doubled. Call down equation 2. What happened? Divide equation 2 by equation 1. Divide equation 2 by equation 1. What is equation 2? R1 K into 2A raised to power 2, 2B raised to power minus 1 over R over K, A raised to power 2, we have B raised to power minus 1. What happened from here? K cancel what? K, R1, R, this one you have 4 into what? A raised to power 2. This one you have 2 raised to power minus 1. Then you have B raised to power minus 1. Everything you have A raised to power 2, B raised to power minus 1. Know that this minus 1 we have had this, we have had this. This 2 we have had this, we have had this. 2 have had this, that is 4. Then this one we have this raised to power minus 1. Then what happened? This cancel this cancel this. Isn't it? That's what you have. From there now, R1 over R equal to this one we have 4. This one is what? We have 1 times, this one is what? Times 1 over 2. 2 here, 1, 2 here. We have R1 over R equal to what? 2. Therefore, R1 equal to what? 2R. In this case also, rate of reaction increases by 2. Rate of reaction increases by 2, or increases 2 times. 2 times. Increases 2 times. Rate of reaction increases 2 times. Take note of that. Let's go to the last one under question 2. Volume of container increases by 2 times. That's volume of container increases by 2 times. Volume increases by what? 2 times. Increases by 2 times. That is common figure 4. Increases 2 times. Increases 2 times. Take note before we know this. Concentration is inversely proportional to volume. Take note of this statement. Concentration is inversely proportional to volume. If concentration increases, what happens to volume? Decreases. If volume increases, what happens to concentration? Decreases. Then if volume increases 2 times, what happens to concentration? It decreases 2 times. What is the meaning? That's the meaning. If volume increases 2 times, concentration decreases what? 2 times. Because concentration is inversely proportional to volume. In this case, that means the concentration of A and B, they are both in the container, will decrease what? 2 times. That means concentration of A and B decreases 2 times. That's the meaning of that statement. If volume increases, volume of container increases 2 times. Therefore, concentration decreases 2 times. A and B are in the container. Their concentration will decrease 2 times. That's what we wanted to do. That means from here we have the equation is still R. The rate law for the question is what? Still R equal to K into A raised to power 2, B raised to power minus 1. Then R1, this is equation 1. When volume increases 2 times, concentration decreases 2 times. That means concentration of A is halved. Concentration of B is also halved. That's the meaning of equation 1, 2. That's the meaning. That's the meaning. Divide equation 2 by equation 1. What do we have? R1 over R equal to what? K into what? A over 2 raised to power 2. B over 2 raised to power minus 1 over K. A raised to power what? 2. B raised to power minus 1. Do your simple mathematics, no wrong. I can just say from here, this one, cancel this one, 1 over, this one, cancel 1 over. But if you are just be calm with your mathematics, in this case, be calm. Be calm, don't rush, be calm, be calm. This thing, it means what? You have R1 over R equal to K cancel K. You know that you have this, you have A squared times what? 1 over 2 squared. Be calm. Then for this one we have B raised to power minus 1, then times what? 1 over 2 raised to power minus 1. For here, then over you have A raised to power 2, B raised to power minus 1. What I'm doing, this one can be because then from here, what do you have? Be calm with your mathematics, no rush. R1 over R equal to what do you have here? You have 1 over 4. This one we have, this one will give you 2. Therefore, we have R1 over R equal to what? 2 over 4. 2 here 1, 2 here 2. We have R1 over R equal to 1 over 2. Therefore, we have R1 equal to what? R over 2. In this case, what happened? Rate of reaction decreases 2 times. Rate of reaction decreases 2 times. Rate of reaction decreases 2 times. Take note. You can pause your video and watch it, do it your own before. Let's go to the third one, the third question, which is the last one. Please subscribe to this channel, please, because we still have many things to give you. We still have order of reaction, first order, second order, zero order. We have integrated law. We have 4 ways to determine order of reactions. 4 methods. We have what? Half-life method. We have integrated law method. We have what? Initial concentration method. And we have graphical method. And we are going to treat everything. For each order of reaction, we do integrated law method, we do half-life method, we do initial concentration method, we do graphical method. We still have more video and more questions to come out on it. Please subscribe to our YouTube channel, share with your friend, comment and like. Please, may God bless you. Let's go to the second question. The last 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 question. Go the well, I'm tired. Only like to see you so smile. Only like to see you so. Only set of vampire. Fight against advantage. Fight against pressure. Okay, the last one. It says 3A plus 2B give you a product experimentally. And I say when A is doubled alone, ROR increases 2 times. When concentration of A and B is doubled, rate of reaction increases 8 times. Write the rate law equation. Find order of the reaction. Listen, we all know for concentration of A and B, we have R equal to what? K, A raised to power X, B raised to power what? Y. You know this law, rate law, experimentally, that's what we have. Now say when A is doubled alone, ROR increases 2 times. Let me call this one equation 1. When A is doubled, rate of reaction increases for 2 times. It increases 2 times. When A is doubled. When A is doubled. Let me call this equation what? 2. When A and B, when concentration of A, concentration, this thing means concentration, I told you in the first class. When concentration of A and B is doubled, rate of reaction increases 8 times. It increases 8 times when concentration of A and B are doubled. When A and B are doubled. A and B are what? Doubled. We now say find order of reaction and write the rate law equation. Very simple. What can I do? For me to look for what? X, I can eliminate what? B. I can eliminate Y. What will I do? Divide equation 2 by what? Equation 1. Divide equation 2 by equation 1 so that I can get my what? X. Divide equation 2 by equation what? 1. Divide equation 2 by equation 1. That means to calculate X, divide equation 2 by equation 1. I have 2R over equation 1 R equal to equation 2 is what? K into what? 2A raised to power X B raised to power Y. Then over equation 1 I have K into A raised to power X B raised to power what? Y. What happened? R cancel R. We have 2 over 1 equal to K cancel what? K. What happened here? This one cancel this one. What happened here? Here you have what? 2 raised to power X A raised to power X. That means separate this. Mathematics. That means this S affects A, it affects 2. It affects 2, it affects A. Then over what? A raised to power what? X. What happened? This one cancel this one. What do you have? You have, from here now, you have 2 equal to what? 2 raised to power what? X. From here, what do you have? You have S equal to 1. 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 I've gotten S as 1. Then for me to calculate Y, divide equation 3 by equation 1. Divide equation 3 by equation 1 to get Y. To get Y, that means divide equation 3 by equation 1. What is equation 3? I have 8R equal to what? K into what? 2A raised to power X B, 2B rather, I'm sorry, 2B raised to power Y. Then equation 1 over R, that means over K into A raised to power X B raised to power what? Y. I have this. From here, what do I have? This one cancels this. You have 8 over 1 equal to this one cancel this. Right? Yes. What do you have? From here, you have 2 raised to power X. I mean, this one will cancel this one. I don't need to. Then what do we have? We have 2 raised to power what? Y. This one has cancelled. Let me write it properly for those of us. You have 2 raised to power X. A raised to power X. For this, I will have 2 raised to power Y. B raised to power what? Y. Over A raised to power X. B raised to power what? Y. From here, this one cancel this. This one cancel this. That's the meaning. Then from here, I have 8 over 1 equal to what? 2 raised to power X times 2 raised to power what? Y. Law of indices. A raised to power N times A raised to power N. The same base. A. Then N plus N. The same base. The same base. That means from here, I will have 8 equal to the same base. 2 raised to power X plus Y. 2 raised to power X plus Y. Let me go up that one. From here, what will I have? I have this. Take this one to what? Index. I will have 2 raised to power 3 equal to what? 2 raised to power X plus Y. What happened? I have 3 equal to what? X plus Y. What is my X? 1. 3 equal to X is 1. 1 plus, what happened? You have Y equal to what? 3 minus 1. You have Y equal to what? 2. Y equal to 2. S1. Y equal to what? 2. Then, now, write the rate law equation, find order of reaction. Very easy. Write the rate law equation. Write the rate law equation and find order of reaction. Find rate law equation. What is the rate law equation? R equal to what? K into A raised to power X. What is my X? 1. 1. Then B raised to power y. What is my y? B raised to power y. B raised to power y. What is my y? 2. That is the rate law expression. Rate law expression. But the next question says, find the order of what? Reaction. Order of reaction, n equal to 1 plus 2. N equal to 3. That is that. Please, for more video, subscribe, share, comment. Please, if there's anything you want us to do, please call one of those numbers above. And if you want to buy course, if you want us to teach you privately, you can call one of those numbers. Thank you.